If it's only you, not everybody else, then it could be your car. Okay, now we're live. So last week we introduced the command line. For those of us who have no command line experience, we started from the ground. So okay, here's how you list files from the command line, so you can kind of see what's in the different directories. Here's how you change directories. You know, just the basic what you'd call navigation commands. How to move around your system from the command line so that we get comfortable using the command line. Today, I'm going to start talking about working with files and text. And this, in terms of the usefulness of Linux as a technical tool, right? For use, to use Linux to do things like research or data analysis, all that kind of stuff. These are the tools that are available that make Linux useful. All right, so one of the things that we're gonna be working with a lot are plain text files, right? We're gonna work with plain text files much more often than you are probably used to working with plain text files if you're using like a Windows machine, or if you're using just programs like Microsoft Word or Excel or whatever the notes program on Apple is. But text files, and specifically plain text files, are a big piece of all of the analysis that we're going to do. So what is a plain text file? Let's just look at an example of the difference between a plain text file and a non-plain text file. I'm going to create a document using LibreOffice. So LibreOffice is the name of the Office suite that provides things like a word processor, an Excel-style spreadsheet, presentations, for doing slides. So LibreOffice is going to be in the Office section, and so I've got several different LibreOffice programs that I can use. Let's just do LibreOffice Writer. That's the equivalent of Microsoft Word, right? So let's say you're going to write like a tech report, your lab report, you're going to use LibreOffice Writer. So I'm going to create a document. This is a document. And then I'm going to save this document. So let's just save it to my documents folder. Go up here to File, Save. I got to pick a place to save it. Looks like it's already in my documents folder, so I'm going to call this Document 1. That way there's no way of telling what's actually in there without opening it up, right? Wouldn't want to name it like assignment number 1, semester 2017 spring or something like that. So you look at Deo's desktop, it's just littered with files that are all named like presentation 2, conference files, just random stuff. Yeah, oh yeah. Oh, it's right there where you can get to it, right on the desktop, real handy. All right, so I created that file. Now I'm going to close this. Now I'm going to create a plain text file. I'm going to open up Pluma. Now I don't use Pluma, but that's apparently the text editor that's installed on this Linux Mint Debian edition. And so the easiest way to find that is to go down here into search and type in text. And this text editor is what I'm going to open up. And so it opens up something that looks similar, right? It's got a window. There's an open, save, print. So this I'm going to put in plain text file, and I'm going to save this. And let's go to my documents again. And let's just call this, if you want to see this work on your machine, yeah. You don't have to, though. Documents. Okay, I'm going to call this file 1. All right, now I'm going to save. All right, now let's open up a terminal. Let's go into that directory and let's run the cat command on each, which we'll discuss later. But the cat command basically just takes what's ever in a file and it prints it to screen. It allows you to look at the contents of a file without opening up the file. Now, cat stands for concatenate, so really you can also take multiple files and put them together to create one file. But we're just going to use it to see what's in these files. So I'm going to open up a terminal, and I'm going to go to my documents. And I see that there's two files there. One says .odt. That's the one that LibreOffice created. And it added that .odt for me automatically. And then the other one is called file1, and it did not add. That was the one I used Pluma for. It did not add an extension. But if I cat file1, I see this is a plain text file. It's exactly what I typed in to the file. So it looks exactly like the stuff that I typed in. If I cat the document1.odt, I get this. Right, so this, yeah, it's beautiful. It's like the Matrix. This is a bunch of what appears to be random characters. That's because this file isn't plain text. It's got extra stuff in that file. And we can understand why it has to have extra stuff in the file. In fact, it's actually toes my terminal. Like I can't even type stuff in the terminal anymore, right? So I'm gonna have to close this. Let me go back in there. Try to open this up with LibreOffice. All right, so look at the stuff that's in this file. Like you guys know how to use this, right? These are the margins. I can change the margins for my document. So if I've got a paper that requires one page, but I really want to write a half a page, you just make these margins really big, right? You can also double space. You can do things like this is bold. You can highlight this and make it bold. Now, how does that get saved? Right? It's obviously this file contains more than just the stuff that I typed. It contains extra information that tells it what size the margin should be, what text should be bold, do I have a pretty background set, what's the font? All of that information has to be in that file, which means that there's extra information outside of just the text that is in that file. So this isn't a plain text file. There's all kinds of different formats. Like, you know, the thing that we just saw opened up at the screen, you know, the random characters that popped up correspond to some bits, some zeros and ones that the LibreOffice program knows how to interpret, and it knows how to turn it into this. Right? But it's not just plain text. So what we're going to be dealing with is plain text. We're not going to be dealing with these Word, Word style documents. So if I tell you to create a file, you don't want to open up LibreOffice and try to create the file. You're going to want to open it up in a text editor to create the file. Yes.
So I know LibreOffice will open up a Word document like the Microsoft Word document, but will Microsoft Word open up LibreOffice document?
It depends which format you save to. Yeah, you can, well, LibreOffice can write to Word document format, but then this ODT stands for like Open Documents. What's that? Something. I believe that the OD is an open document format. So there's a standard sort of document format that they're trying to push, and Microsoft Office, I believe, has support for those things now. So it's not, it's a little bit easier to switch back and forth between them, but you're not, you know, I've never had really good experiences with trying to edit files in both Word and LibreOffice. The formatting always looks a little bit different, and it's just not a very pleasant experience. If I try to open this up in Pluma, Pluma tells me that it can't even figure out what the encoding is. Right? So there's some extra stuff in there that is in addition to plain text. And so what we're going to be working with are plain text files. Right? Anytime you write a program, you're going to write your data to plain text files, unless you're writing really big data sets, and then you might write it to binary. But everything that we're going to do is going to be plain text. So plain text means it just contains text. All right, so let's learn some commands that allow us to look at file content. We've already seen or saw, Derek? We've already seen. We have already seen.
Yes, sure. Yeah.
Okay, we've already seen the cat command. The cat command just prints the contents of a file to the screen. There's some other commands that are very useful, especially if you're like trying to figure out where something is. Like if you've got a bunch of files in a directory, or you've got several directories that contain several files, and you're trying to find something in that directory, there's a lot of commands that are useful for doing this. The head command prints out the first 10 lines of a file. So cat will print them all, Head will print the first 10. Tail then prints the last 10 lines of a file to the screen. grep will actually look for patterns and then print all matches to that pattern. So grep is like running Control F to find something in your document without actually having to open the document and being able to do it on multiple documents at once. Right? So I can say, well, I know that there is, that some of these files contain the word warning. I want to find all files that contain the word warning and then show the line that that warning appears on. That's what the grep command does for us. WC stands for word count, and it will count the number of lines, words, and characters. This is often a useful command if you're just trying to figure out, are there any non-empty files in this directory? Like I ran this code, it's supposed to write data to these files. Do all of these files actually contain lines of data in them? You run the word count command on it, and it gives you a summary of how many words and lines and characters there are. And then less will open up a file in a pager. And a pager, we'll see what that means, but it basically allows you to scroll through the text of a file. All right, so I've got a follow along. Everybody has already downloaded the sandbox, I assume, right? You've got the sandbox open. So I'm going to go into the sandbox and do some, sort of see how these commands work. All right, I'm going to go to my home directory first. I'm going to go to my sandboxes directory, and then I'm going to untar the sandbox. The sandbox would have been stored in the downloads directory. So Derek, it's TAC-X for extract. J is the compression that we're looking for, TAC-J, and then TAC-F to give the name of the tar file. All right, so that should create a directory that is just named after today's date. All right, there's a directory in here called inputs, and I'm going to go into the inputs directory to start using these different commands. All right, let's just see what's in the inputs directory. All right, so I've got several files, some files that are called database something.bin, and some files that are called file something.txt. So let's just see what the cat command does. All right, so there's a file called file tag00.txt, and I'm just going to cat that, and that is going to print the contents of that file. Now in this case, I've just created a bunch of files that have their name in them, and then every line has the line number printed so that we can actually see that, for example, this would be line 7 out of the file called file.00 or tag00. All right, so this file has 15 lines in it. The reason that the cat command is called cat is, as I've said, it will concatenate a couple of files together, right? So I've concatenated, well, excuse me. First, I printed out the contents of file 00, and now I've printed out the contents of file 01. You can see that they're almost the same, except that the file name inside the files is different. And if I just list both of these together, concatenate means take the first file and then put the second file's contents right after it, right? Basically make one long listing of the file contents, and that's what cat does. Yeah.
Will that only work on text files, or could you put, say, a part of the text file would delete ODT?
Yeah, you could do that. And it's not, I mean, you'll break the ODT format. So now the, like LibreOffice probably is not going to think that it's a file that's, it's going to think that it's corrupt is what's going to happen, and it's not going to be able to open it probably. All right, so I ran cat on these two, and if you look, right, here's the boundary between the two files. Right? So those just there's nothing that indicates that, that this content comes from different files. This is a way for me to get the content of the two files together. And what we're going to see later on is that we can always take this, and instead of printing it to the screen, we can always send it and save it in another file. And so the cat command allows you to take things from multiple files and then combine them into a single file. Right? That's the main use of it. If I change the order of the arguments in the cat command, it's just going to go through the arguments one at a time, starting with the first one, and the first one is the one on the left, right? The one that's closest to the cat command. So right now you can see that all of the lines have been printed with file 00 up here and 01 down here. If I change the order of the arguments, I'm going to get all of the same lines, but now 01 is up here and 00 is down here. And we already talked about this last class period. The shell provides wildcard expansion. And so I can give file names with patterns, and then the files that match that pattern are going to be handed off to the command by the shell. So I can print the contents of all files in this directory that start with file and end with .txt by just passing the cat command a file star.txt. And so here I can see that all of the files were listed one right after the other. Now, here is the reason why I have all of these files numbered 00, 01, 02, 03, and 04. Because when I do this pattern, like how do I know what the order that the files are going to go to the cat command if I use the pattern? Well, the shell is going to create the list of files that match the pattern, and then it's going to sort them. But it's going to sort them based on the ASCII value. And so if I have files, for example, if I had a file named fileTac1.txt, and then I had a file named fileTac10, so I've got 1 and 10, those would not sort according to 1 and 10. I would get 1 and 10 sorted right after each other, and then 2 would follow 10. The way that you get around that, well, there's tricks to do the sorting correctly, but the way that you get around it without having to do any tricks is to just pad all of your numbers and file names with zeros. That way they'll sort on the command line correctly. That's also the reason why these sandboxes are named with the year first, then the month, then the date or the day, and those are all zero padded as well, so that they will actually sort correctly if you list the contents of a directory. All right, so that's the cat command. Sometimes the cat command produces too much output, especially if all you're trying to do is just see what's in a file. Like you're just looking for a file that's got something in it that you know exists. Like you're looking for the data that was produced from an experiment that ran on January 4th, and you know that information is in the file somewhere, and you're just trying to find it. The cat command can produce a lot of output that you don't actually want to sift through, and that's where the head command comes in useful. The head command prints the first 10 lines of a text file. So I'm going to run head on the 00 file, and this time instead of it printing lines that say 1 all the way through 15, it's just 1 through 10. Print the contents of file 1, and I get the first 10 lines. The nice thing about the head command is that unlike the cat command, which is made to concatenate file output, the head command is really just to help you grab like the first 10 lines of something and look at it, grab the first 10 lines of a file. So if I run head with multiple files, what it'll actually do is print out the first 10 lines of those multiple files, but right above the first 10 lines, it actually prints a little header here that tells me what file it came out of. So I can print out the first 10 lines of a bunch of files and then actually see the file name above the line listings. Right? So head is really meant to sort of, just look at a bunch of files real quick, or to just grab the first 10 lines of some stream of lines that are coming. If I change the output order, I'm going to change the order of the listing, but again, it's still going to give me the file name above the first 10 lines of each file. Right? So this is file 1, and this is file 0. And if I do, again, the shell pattern matching, I'll get a listing for the first 10 lines of all of these files, but they all have the file name above them. So this is useful to see which file contains the stuff that I'm looking for, if you're going to search through it by hand. Now, the head command does take an option. The most common option that I use is the tac-in option, which stands for number of lines, I guess. Like how many lines do you want to print? By default, this is 10. But if you really just wanted to see the top line of every file, then you'd use tac-in 1. That tells head to just print out the first line of the file. Now, if I only give it one file argument, it doesn't print that header that tells me the file that it came out of. That only occurs if I print if I'm looking at the, or if I give multiple files as arguments. So if I run head tack in with all of these files, I'm going to get a listing. Here's all of the file names, right? File 00, 01, 02, and then this is the first line of every file. And so the first line of every file says line 1, and it's got the file name in it. I've already mentioned that tail does essentially, it's not the opposite, but it does the same thing as head, except it does it on the bottom of the file. So maybe you know, for example, programs that write log status information to files are going to add that status information to the end of the file. So if you want to see what's the latest status information that this program has written to its log, you're going to want to see the end of the file, right? And so you would run tail on a file to see the end. So here I've got lines 6 through 15, which are being printed. I can run it on multiple files. It does basically the same thing that head does. It just does the last 10 lines instead of the first 10 lines. So if I give it multiple files, it is also going to print out the file name for me so that I can see that these are the last 10 lines of this file. Tail also takes the same option as head, tack in. So these two are basically complements of each other. They probably were written at the same time. But we're going to find that this is not, there is no standard naming convention for options, right? Different commands that we use are going to have options that basically mean number of lines that you want to output, but they're not going to be called tack in for some reason. Or it'll, there'll be commands that specify which column of text do you want to do this to, and they don't use a standard notation on what to call it. But head and tail are basically the same command, so they both support the tack in option, and that you can give, tack in 2 is going to print out the last 2 lines. Tack in 3 will print out the last 3 lines. If I do multiple files, again, I'll get a listing. These are all of the last lines for the files, and I get a listing of the file name with the last line. All right, now, head and tail are going to be useful for just sort of quickly looking at a couple of files to see if you can see immediately what it is that you're looking for. But if you've got something that is buried inside of thousands of files or in subdirectories that contain thousands of files that you're looking for, you're not going to run head on every one of those files and see if it contains the stuff that you want. And that's where grep comes in. So grep is for searching files for a pattern. And grep takes 2 arguments at least. The first argument is always the pattern. So the grep command looks like this, right? grep. The first argument is the pattern that you want to match. And remember, if I have spaces in my argument, I have to quote them. Otherwise, the shell doesn't know that there's supposed to be a single argument, right? So I'm going to look for the pattern line 05. So that's the first argument to grep, is the pattern that I want to look for. And then I'm going to give it the name of the file that I want to search for it in. So we see that all of these files contain, if I go up here, oh, I got to go a ways, right here, right? So they all contain a line that says line 05. So we know that that pattern's in there. So what the grep command is going to do is it's going to find that line that matches line 05, and it's going to just print that line. So if I've got a pattern in there that I know I'm interested in, I don't have to worry about the rest of the contents of the file. I'm just going to get the line that matches this pattern with grep, which is also a good way to tell if that pattern exists in the file, right? If you search for something that doesn't exist, grep just prints out nothing to the screen. So here I get the line that matched. And then our terminal, or our shell, I think this might be the shell that's doing this, is color coding this for us, which is nice, right? It actually, in red, shows you the exact piece of that line that matched the pattern that you're looking for. This is a very common use case. You run grep, give it the name of the pattern that you are looking for, and then you just give it every file that's in the directory. Or as we saw last time, if I had a bunch of files in subdirectories, I could use a star and a slash to say all files that are in the subdirectories of this directory. And so this is going to give me a listing of all of the lines that match the pattern from all of the files. Now, when I do this, you'll see that the output is slightly different than it was before, just like head and tail, right? So if I only give one file, then head and tail assume that I know what file it is that I've given it, and they're just going to print out the first 10 or last 10 lines of the file that I've given. Same with grep. If I just give it one file, it's just going to print out the line that matches the pattern that I asked for. If I give it multiple files, it's actually going to show me the file name and then the line that matched. So this first part here in purple is the file name that matched the pattern. And then there's a colon, and then this stuff after the colon is the actual line that matched. So I can see that all 5 of these files contained a line that said line 5. All right, now I'm going to run the same grep command, but I'm going to do it on the files that end with bin. So star.bin. And I've got 2 different types of files or lines that match this pattern in this. I've got in database 0, 1, 2, 3, and 4, I've got the same line that I had in all of the other ones, right? It just contains the file name and it contains the line number. But then I've got another set from 5 to 9 which have this reversed. So line 5 comes first, then I have the file name. Now, sometimes you want one or the other. You're actually not looking for both of these, right? And in this case, it's not too bad. You just look at the 5 that contain the version that you want, and you could write down what those file names are. But if you're dealing with thousands of files, right, you don't want to have to go through this output automatically. And so what you can do is you can tell grep to limit the things that match this pattern. And it's beyond the scope of what we're doing right now, but eventually we will start talking about regular expressions. So this pattern that grep is using, it's called a regular expression. There's a chapter on regular expressions in your book. They're basically a syntax that allow you to very precisely, although convolutedly, I mean, it's really hard to read regular expressions, but it very precisely define exactly what it is that you want to match. And so one of the things that a regular expression allows you to do is you can put a caret here at the beginning. And a caret means match the beginning of a line. So this pattern is saying, I want to match line 05, but only if it's at the beginning of a line, right? If it's somewhere else in the line, that doesn't match the pattern. So if I do that pattern on the same set of files that I did before, I see that only the ones that have lines that begin with line 5 are now listed. So that's what the regular expression support for grep allows me to really narrow down the pattern that's going to match. The pattern by default is case sensitive, right? So if I search for line 5, but I capitalize line, that which we know exists in lowercase in this file 00 is not going to match that line, right? So I get nothing printed by grep. So there's some options that you might find useful for grep. One of them is the ignore case option. So that's TAC I. So if I really don't care if it's uppercase or lowercase, I just want to know if that pattern is in the file, I can give it a TAC I option that will now match things ignoring the case.
There's like a line 5 and a line 5 where you have a capital L and a lowercase l, and it'll pull up both.
Yeah, both of those would be matched. Another common option that you might want to use with the grep command is to say, show me all things that don't match this pattern. So in a file, every line is either classified as does match or does not match. By default, you're going to get a listing of the ones that do match. Sometimes you want a listing of the ones that don't match, just the inverse set. So what it's called? The complement, I guess. Has anybody taken group theory or what's that? Corey, what is that math class where they talk about sets?
Graph theory?
There, I'm talking. Have you taken that specific class?
I know somebody has.
Yeah, I can't remember what it is. I'm thinking of a specific class that probably Riazi teaches because he teaches all of them.
Yeah, he does. He just goes really hard.
So
many.
So if you have a set and then you have a subset, right? The complement of that subset is everything else that's in the set but not in the subset type of thing. So anyways, that's basically what we got here. So if you want to see all the lines that don't match the pattern, you put a TAC V on there, and then you get a listing of all of the lines in the file except for the one that said line 5. And you can mix these options. So I can use the TAC V to say, inverse the pattern or the match, and then TAC I to say ignore case, right? So for every line, check to see if it matches the pattern, ignoring case, and then show me all of the ones that don't. And that gives me a listing without the number 5. And then the last option, grep has a ton of options, but the last one that I'll share with you that I find myself using sometimes is TAC C, which means count the number of occurrences of this pattern. So this is going to be useful if you don't really care to see the lines that match. You just want to know how many of them there are, right? So you want to know how many lines contain the word error on it, and you want to know what files have that pattern in them, and you want to for each file count the number of occurrences. So if I do grep TAC C line 5 and I look in the first file, I get a listing that tells me there's 1 occurrence of that. Well, we know that that's true because every time we ran this, we saw 1 line that gets printed. If I do the same thing, but now I'm giving it multiple files, well, now it's going to give me a summary for every file, how many matches were in that file. And so it's almost the same as it was before, except instead of the line that matches showing up here, I get the file name and then the number of occurrences. And all of the stuff that we're doing right now just matches 1 line. If it matched more than 1 line, we'd see numbers greater than 1 show up here. All right, I mentioned WC, that stands for word count. I almost never use it to count the number of words or characters, but it also counts the number of lines, and I find that useful a lot of times. So if you type WC and you give it a file, it will print out a summary of what's in that file in terms of how many lines are in that file. Well, there's 15 lines, that's the first thing. How many words are in that file? Those are characters that are separated by spaces. There's 45. And then how many characters are in that file? So there's 405 individual characters that make up that file, and that's file 00. So if I give it more than 1 file at once, it'll give me a summary of all of those files. If all I really care about is the number of lines in that file, then I do WC TAC L, and it prints out just the number of lines in the file. This is what I use to, this is one command that I use to grade the homework. I do a listing of the number of files that you have in your homework submission, and then I use WC to count the number of lines that get printed to the screen, and I can tell if that's 1 or greater than 1 or less than 1. Yes?
So if we wanted to find, if we have a file or directory of things and then a directory of files, can we say word count that directory / star, and then it'll count out all of the different
Let's see here. So are you thinking, like, if I do ls, what's in Etsy? If I do word count Etsy star, what is that going to do? Yeah, it's going to look like that. So these are a bunch of empty files. If I do word count, the one that we were in is what? We're in inputs. Then yeah, I get a listing of all of these things.
You've seen the ending of bin. What are those?
That's a just a naming convention. That would usually stand for a binary file.
Okay.
So one that's not encoded in ASCII but contains binary data. It's common if you're running simulations or you're doing like processing on data that was collected with like a LabVIEW sort of setup, that you might run into these bin files that get created. ASCII's plain text. So ASCII is the encoding for how like every character is represented by a number. So B has a number that's associated with it. That's how the computer represents all of the letters. So the bin files in this directory are a little bit longer than the text files. They contain 144 lines. I can get a listing of all of the text files, and then I actually see a summary. So it says that each one of these contains 15 lines, but added all together, there's actually 75 lines that are listed here. All right, and then the last thing I want to discuss for this part is what happens if you've got a file that's really big. Well, it's going to be a pain to use CAT to look at that file because it's basically just going to fill up your screen, right? You're going to have to scroll past it. So this file that I have here is not very big. It's only got 15 lines. I run CAT on that. I get the listing of all of the lines in that file, and it fits on my terminal. But this bin file, which we know is bigger, contains 144 lines instead of 15. If I CAT that file, I'm going to get all of the lines just sort of going shooting past me, right? And I'd have to scroll up to do that. And there's a limit to how far back you can scroll. It's pretty big. I mean, it's not a, in this case, it looks like I'm a quarter of the way through my history, but there's a limit to how far back you can scroll up. So it's possible if you just CAT a file, that you actually scroll, or it goes past your scroll point so that you actually can't even see the whole file in the terminal. And so there's tools that are made for this case specifically. And the command that does this is called less. So if I run less on a file name, it's going to open up the file in a pager, which basically just prints the contents of the file to the screen, but allows me to actually go up and down in the file. So if I run less on a file, it opens up like this, right? This is the contents of the file. But I have the ability to, if I use the arrows, I can go up and down in this file. So this is a way for me to look at the contents of a file. I can also use J and K to go up and down in the file if I don't want to use the arrows, or my computer doesn't have arrow keys because they got broken off or something. J and K are the scrolling keys for VI, which is a text editor that's very popular. So less allows me to do exactly this, right? I can scroll through this file without all of the file contents going past me, and I don't have to use the scroll in the text or the terminal. So to get out of this, you type Q. You type Q, that takes you out of the less pager. Now, you might be wondering, probably not, you might be wondering why it's called less. That's because originally there was a command called more that did this, right? So CAT does what? Prints all the stuff in a file to the screen. If that's too much and you want to actually say, hey, stop, just print out whatever fits on my screen and then allow me to scroll through it, that command that did that was called more. And so this is the output of more. It looks very much like less. The only difference is that I can scroll down, but I can't scroll up. The way that I scroll down is I hit the enter button. Now, if I go past, like so I've gotten line 12 is at the top, there's no way to go back. All this allows me to do is to just see more and more of the output that was generated by the CAT command, or excuse me, in this case, by looking at the contents of the file. And so this command was basically improved. The person who wrote it decided to call it less because it's the opposite of more, and less allows you to scroll up and down. So typically, you're always going to use less as your pager, but more is a command that still exists on all these systems. With more, when you get to the bottom, so I'm almost there, right? 94%, 95. When you get to the bottom, you hit enter one last time, and then it just automatically closes. So really, you're only allowed to scroll through it one time. All right. So those are the commands that are most useful when you're just trying to look at the stuff that's in a set of files, right? And these are just commands that essentially print contents of files to the screen in one way or another. Either all of the stuff that's in a file, just the first 10 lines, the last 10 lines, only lines that match a certain thing, that sort of thing. All right, the last thing that I want to talk about today is file redirection. And this is a really nice feature of the terminal. Basically, anything that gets printed to the screen can be saved to a file. Right? So if any command that I run that produces something that gets printed to the screen, if I wanted to save that in a file, I can do that with file redirection. And the syntax, or the way that you do that, is that you give a greater than sign after the command that produces the output, and then you give it a file name. And anything that the command produces, meaning anything that it would normally print to the screen, gets sent to a file that has the name of what you give to the right-hand side. So, you know, the way I remember, because you can also put the less than sign, but you just imagine that this command is producing things that are getting funneled into this file. They're going to be saved in that file. Now, there are two ways to do this. If you give a single greater than sign, it will overwrite this file if it exists. So you do have to be careful with this. If you got stuff in a file that you care about, you can accidentally overwrite that file with this. The double greater than sign will append to a file. So if you've got a file that already exists and you just want to add the output of a command to the end of that file, then you use the double greater than sign. That will append. So some examples would be tail tack in 1, right? Tack in 1 says print out the last line of this file. So this is going to print out all the last line of all files that are TXT files. And then instead of sending that to the screen, I'm just going to save that in a file. Now I have a file which contains the last lines of every .txt file. If I wanted to then add, not overwrite, but I wanted to add the last lines of all of the .bin files, I would not use a single greater than, I would use 2 of them, and they're not separated by spaces, they're together. And then that would actually add the last lines of all of the bin files to the same file that I just created. And then if I did the same thing for log files, but I left it as a single greater than sign, this would overwrite the file that I had just created, excuse me. And this last lines.txt would now contain just the last lines of the log files. So anything.
So that's good for we could use that to save like the commands we used for our Blackboard homework.
Exactly. Yeah. Like you've got tasks that say how many files were there in the subdirectory, right? Well, you could list out the files in the directories like you would normally do and count them. But then you could, once you get that command right, you could save the outputs to like a file named task1.1. And then you'd always have that, so you wouldn't have to go back through and rerun it. You could just go through and look at your text files to answer the quiz questions. Absolutely.
And where does it save that file at?
In the current working directory. This can be this accepts a relative or absolute path. So if you just give the name of a file, that's implied relative path in this directory. But if you did like .. lines _ last lines, then it would create a file in the directory above where you are. So that's going to be very useful. All right, we're going to pick back up on this Wednesday. Do not forget to resubmit your homework if you want more possible points, I guess, if you want more credit.
I can take you up on that. Start in the hole. Hey, I do like starting with the hole. I like your background. I like the US.